Hello and welcome back. In this part of the course, we will give an example that resembles the pipeline and the stages that you will be going through over and over while working in a machine learning area. So the process simply, as we talked about earlier, you start with data, which you may have to do some pre-processing to it, and then you apply a machine learning algorithm, you build a model, then you evaluate the model and do some analysis to determine how good is your model and gain some insights that you did not know previously. These are the overall stages of solving a machine learning problem. Initially, we start with a question or a problem that we hope that the data that we have can help us answer. So here is a very clear, tidy data set in CSV format where you have got variables in columns and observations in rows. The data seems organized and ready to be analyzed. It's important to note that it is very rare that the data comes processed and ready before the beginning of a study. You may have to do some cleaning and pre-processing yourself to get it to this form, as we mentioned in the machine learning process stages. However, we will assume that it is, or someone has done it for us. So your job is to apply machine learning algorithm to it and do some analysis. First thing, we hope when we are receiving the dataset that it comes of what we call codebook, which is a file that gives us general information about the dataset. For example, what each variable means, what are the units of measurements, hopefully some stats about the observations, how it is collected, and the date of collection, and so on. This dataset that we're going to be working with has a codebook, so let's look at it. As you can see here, the file contains the dataset name, which is the IRIS-Plan database, when it was last updated, and the source. We also see some past publications that used this dataset. Here we can see the description of the dataset, which is extremely nice. How many attributes and instances in the file, the formats, the unit, some statistics about the dataset. So let's go through some of this information. First, the dataset contains 3 classes of 50 instances each, where each class refers to a type of an iris plant. The number of instances is 150, 50 for each of these 3 classes. The attributes are numeric, and there is no missing attributes. This is excellent. If the attributes were not numeric, we would have to handle it somehow. If there are missing attributes, we will have to handle it somehow. These are valid real situations that you will face, and you will see how to resolve these issues and more in the next course. So as of this dataset, everything is complete and ready, as we can see from the codebook. And we have a good overall picture about the dataset and what we are expecting to see inside the file. So let's check out the CSV file. Okay, the 4 attributes are labeled x1 to x4, which is not a good name. Usually we want the names to be informative, like the height of the tree, the length of the tree, etc. Y is the class which could be one of the 3 iris plants. As we see, there seem to be about 50 of each of the 3 classes. So now that we have seen the file and it matches what the codebook has said, so first let's define the problem. What is the problem that we are trying to resolve? You are required to build a model that can predict the class of the iris plant. So, given a new instant, can you tell us which class it belongs to? using the model that you're going to be building and how confident that you are correct. So, as you can see, our problem is classification. As we have seen in the dataset, we have the input and we also have the classes, which is the expected output. So this is a supervised learning. The learning algorithm that we will be using is decision trees. Details about this method is outside the scope of this course, and it will be discussed in the next one. But for now, we have all the pieces. We have a problem, we have the data ready, we have the machine learning method that we're going to be using. So let's design a solution and do some implementation.